I'm Anil Kumar. Thanks for watching my videos. Here is a very important video on understanding a strategy which can be applied to solve difficult questions based on trigonometric identity. I have three related questions. We need to prove the following identities. The very first one is 1 plus cos x over sin x equals to sin x over 1 minus cos x. Then we have 1 over secant x plus tan x equals to secant x minus tan x. And the third one is 1 plus sin x plus cos x divided by 1 minus sin x plus cos x is equal to 1 plus sin x over cos x. Now these are seemingly not so difficult questions. However, the strategy which I am going to teach you is very critical to understand how to solve similar questions. Let me begin with part A, which is 1 plus cos x over sin x equals to sin x over 1 minus cos x. Now in this particular identity, you will notice that we have few terms on the right side. We need to get sin x over 1 minus cos x from the left side. What we can do is that beginning with the left side, which is 1 plus cos x over sin x, we can multiply and divide this by the factor 1 minus cos x. 1 minus cos x. So if I multiply and divide by 1 minus cos x, now that is as good as 1. Multiplying and dividing by 1 makes no difference, right? But see how it helps us to get the solution. Now when you do that, we have in one step got what we wanted in denominator at least for the right side. Do you see that? Correct? Now we'll maintain that. So in the denominator, we'll keep the terms as such, which is sin x times 1 minus cos x. We are not going to expand it. We need 1 minus cos x. But what extra we have is sin x, which we need to cancel out with the numerator. That is the strategy. So I could see a solution while doing this step. So that is kind of important to understand. Now what is 1 plus cos x times 1 minus cos x? This is 1 minus cos square x, right? 1 minus cos square x. So here I've used a plus b times a minus b is equals to difference of squares, right? So that technique. Now 1 minus cos square x is what? Well, you know sin square x plus cos square x is equal to 1. So 1 minus cos square x will be sin square x, correct? So I could write the numerator as sin square x, and in denominator we have sin x times 1 minus cos x. Now you can cancel one of the sin x factors, and what do you get? Well, what you get is the right side, which is sin x over 1 minus cos x, correct? So we have shown that left side is equals to right side. So I hope you understand and strategy, and I appreciate the strategy which we have applied here, right? So the strategy here is to multiply and divide by a factor which you need, right? So that is what we did here. Let us see how it can be applied in solving or proving part B. Now part B, left side is what for us? Left side is given to us as 1 over secant x plus tan x. What do I need? I need secant x minus tan x. So let me multiply this and divide by secant x minus tan x. Do you see that? Now if I do that, in the numerator, what do I get? In the numerator, I get secant x minus tan x, which is required. And in the denominator, a plus b times a minus b is a square minus b squared, which is secant square x minus tan square x. Now what is denominator equal to? Secant square x minus tan square x is 1, right? So what do we get? We get secant x minus tan x over 1, which is definitely equal to secant x minus tan x. And that is what we need. So left side is same as right hand side, correct? So here the strategy which we have used is again that we have multiplied and divided by the same factor which we need to prove, right? Which is on the right side. So it's kind of an hint, right? Now we're going to apply the same strategy here to prove this particular identity. 1 plus sin x plus cos x over 1 minus sin x plus cos x equals to 1 plus sin x divided by cos x. I would like you to pause the video, answer this question, and then look into my solution. Anyway, let me write down here how I got this last step, right? You know the identity, the trigonometric identity, 1 plus tan square x equals to secant square x. So taking this on the right, you know 1 is equal to secant square x minus tan square x. So that is just a reminder of our Pythagorean identity which has been applied here to get 1, right? So I hope this step is absolutely clear. Now let's move forward and do part C. So I copied this question here. We'll begin with the left side, which is 1 plus sin x plus cos x divided by 1 minus sin x plus cos x. Now the strategy is to multiply and divide by what we need. We'll this time multiply divide by 1 plus sin x. Right, so 1 plus sin x. Now since we need 1 plus sin x in the numerator, we'll not really expand the numerator. However, we'll expand the denominator. So the numerator can now be written as 1 plus sin x plus cos x times 1 plus sin x. In the denominator, we will get 6 terms. First, multiplying by 1, we get 1 minus sin x plus cos x. Now multiplying by sin x, we get plus sin x minus sin square x and plus sin x cos x, correct? Now if you look at it, we have the numerator part, which is 1 plus sin x. We want the denominator to reduce to cos x and cancel out this factor. Can we do it? So have a close look at it. So from here, you can see that sin x and plus sin x cancel out. We have a term with cosine x. We have a term with 1 minus sin square x. Now 1 minus sin square x could be written as cos square x, correct? So if I combine these two terms, I could write this as cos square x, right? Since we know sin square x plus cos square x equals to 1, so we know that cos square x is equals to 1 minus sin square x, correct? So we could now write numerator as such, which is 1 plus sin x plus cos x times 1 plus sin x, and the denominator, combining 1 minus sin square x and writing it as cos square x, we get cos square x. Then we have plus cos x. And the third term is plus sin x cos x. Now in the denominator, we want cos x and see it as a common factor, correct? So we have 1 plus sin x plus cos x times 1 plus sin x divided by, if I take cos x as a common factor, I get cos x plus 1 plus sin x as the other factor. And clearly, these two cancel out, and that was the motive, right? So what is left here is 1 plus sin x divided by cosine x. That is the right side. So again, we have shown that left side is equals to right side, and we have used this very important strategy. And the strategy is to multiply by a factor which you need, right? So that is what works. So the strategy here is times by factor you need, right? So of course when you times, you have to times and divide also, right? Times and divide by the factor you need, as we did in this particular case, right? So that is how you solve such questions. Otherwise, this question could be very difficult to solve. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.